Hello, ladies and gentlemen. My name is Rudy. I am part of the Rite-Solutions Capstone team, and our project is on submarine network fault detection. Our team is being led by our amazing TDs Matthew Pistachio and Matt McAdams. The team is composed of 2 computer engineers, myself, Rudy, and my partner, Thong. Rite-Solutions is a company based in Middletown, Rhode Island. The company's main focus is to help government and commercial clients to gain technical advantages in artificial intelligence, cybersecurity, cloud computing, and model-based systems engineering. For our project motivation, the project focuses on the issue of network fault prevention and analyzing the condition in which a network, especially a switch, can fail by using modern-day concepts of data science. We are specifically focusing on pattern recognition to a network dataset to identify and report evidential conclusions on what led to the point-to-point connection being compromised. Since we don't have access to classified submarine information, we are using a simple network management protocol diagram including a network switch that is analogous to a submarine system. The goal of this project is to research and analyze curated data from publicly available network datasets to identify system component anomalies such as anomalous traffic, anomalous network bandwidth, and more. Ultimately, we want to establish tools that we can host on the Rite-Solutions network and process that can be applied with tactical and production datasets, and finally write a report on our findings. Rite-Solutions are trying to expand their network monitoring and fault detection capabilities for our nation's Department of Defense and upgrading their inter-subsystem monitoring tools. But at the end of this project, we would like to make this public information so that it can be integrated in other future projects. Our proposed plan for our pattern recognition model development, we would first acquire a training data set and put it through data pre-processing. Then we would create a model with assumed parameters, and we are going to train our model using the training set while checking for model accuracy to be as desired. And then we will report our findings on a white paper. These are some of our key technical accomplishments to date as a whole team. We've acquired all of the necessary data sets. We have done some exploratory data analysis on each of the data sets, made a decision on which data set would work best, and created a preliminary findings report. For my individual accomplishments, I created a schedule on what we would do on a week-to-week basis for the entire school year using a waterfall methodology. Afterwards, I performed research on other possible data sets that we could use, such as Crawdad dataset from Dartmouth University and SNMP Management Information Base 2016 dataset, looking for specifically simple network management protocol datasets to see data log from the networks. I also created a decision analysis resolution report to decide which dataset would fit best for this project, using certain criteria such as quantity of the data, amount of feature sets, and relevancy and authenticity of the said data. In the end, a preliminary findings report was created for any course correction from our technical directors to point us in the right direction. For future accomplishments, we would have to create bandwidth calculations to see the correlation between bandwidth utilization and switch fault. Of course, we would assume that our first model accuracy is not going to be up to expectations, so we would try to improve the accuracy for better results. And then finally, we will write up a report on all of our findings so that we can share this information to the public. And now I will pass it on to my partner Thong.
Hi, so my name is Thong, and I personally handle setting up source control using Git so that we can both work and contribute to the project independently. I also propose a plan for the data pre-processing process and implement part of that. I also review all the SNMP data set provided by Rudy and then determined that the University of New South Wales data set would be the best fit for this project. So I went ahead and aggregate all the attack vector that are present within that data set. So for the data preprocessing process, I handle all the exploratory data analysis, which is just checking the data set for its quality, quantity, and authenticity. I also handle all the null, missing, or any duplicate that is present within the UNSW data set, which fortunately there was no duplicate. This is the result of my data attack vector aggregation. As you can see, a lot of the attack is just normal, exploit, or generic. But since we are focusing on bandwidth utilization, I think it's best for the team to focus on denial of service, as this is the attack vector that utilizes the most amount of bandwidth. For my future accomplishment, I think that deciding on another feature of interest besides just denial of service would be good, as another feature would help the model to improve its accuracy. And then I also need to research the correlation between CRC error, CPU usage, and bandwidth utilization versus switch failure. And then based on that research, I need to build a model to detect switch fault. And when the model have a high enough accuracy rate, I will demonstrate that model using the actual UNSW dataset instead of just the training set. So as a team, as I said before, we hope to enhance the quality of the data even further, and then using statistical analysis to build a model to first detect switch fault, and then hopefully to predict switch fault, and then have some data visualization to clearly demonstrate any correlation between CRC error and switch fault. On phase 3, we also hope to publish a formal white paper to demonstrate our findings to the wider public, and also a demonstration of the model using the actual UNSW dataset. A special thank you to both of our TD from Rite-Solutions, Matthew Pistachio and Mac McAdam. They've been great at leading us to where we needed to be. Also a thank you to Jamie Gannon and Brendan for helping us acquiring new data set. And a special thank you to Dr. Sunak for making this program a possibility.